Assalamualaikum and very good evening to Dr. Aris. So we are from group 2. We are going to present the group project, heat transfer and application. So before we start our presentation, let us introduce ourselves first. So my name is Muhammad Izzat Najmi bin Wahab and my matric number is 206870.
Okay, my name is Ahmad Daniel Ismail. My matric number is 208078.
Yeah, my name is Muhammad Nasrullah bin Rozi and my matrix number is 205919.
My name is Ahmad Nazir bin Adnan and my matric number is 208014.
My name is Aiman Amilul Faris bin Kamisan. My matrix number is 208224.
Okay, so without further ado, let us start our presentation. So there is two topic that we'll present this evening, which is the first one is air fryer, which is we are using daily, and the other one is firefighter code that been used in industrial. Next slide. Okay, so before we go through the application, let us know about the background of heat transfer. So heat transfer is the process of the spontaneous transfer of thermal energy from one object or system to another due to a temperature difference. That's a key. And it is a fundamental concept in physics and engineering that plays a crucial role in various natural and man-made process. So we are so there is three process that we are familiar with when we are dealing with the heat transfer project. So the three one is conduction, convection, and radiation. So what is the conduction? So conduction is the transfer of heat through direct contact between particle of substance or between different substance in physical contact. For example, if we have one metal and it is exposed to the high temperature surrounding, and the particle inside the metal will increase the temperature and they will pass the temperature to other particle. So that's for conduction. Convection is the transfer of heat through the movement of a fluid, liquid or gas. So it is related to the temperature surrounding. And radiation is a transfer of heat through electromagnetic wave. For example, there is iron that have higher temperature and they have a metal, and the direct heat that will be exposed to the metal we call radiation. Next slide. Okay, so there are two project goals that we are target. The first one is we are be able to explain and show the application of air fryer for daily life, and the second one is the able to explain and show the application of firefighter code for the industry. So I'll pass to the next presenter.
So for the process in air fryer, firstly, heating element. The air fryer contains a heating element typically located at the top of the appliance. When you turn on the air fryer and set the desired temperature, the heating element begins to generate heat. So for the next process is conduction. The heating element transfers heat to the air fryer internal chamber through conduction. The chamber is usually a metal basket or drawer where you place the food. The heat from the heating element is conducted to the wall of the chamber. For the next process is convection. As the wall of the chamber heat up, they in turn transfer heat to the surrounding air through convection. The hot air rises due to its lower density and creating a convection current within the air fryer. For the air circulation, air fryer are equipped with a fan that circulate the hot air inside the chamber. The fan helps distribute the heat evenly and ensure that the food is cooking uniformly from all sides. The movement of the hot air also helps to speed up the cooking process, and the food absorbs the heat from the hot air, causing its temperature to rise and ready to eat. For the next slide, I pass to the next presenter.
Okay, thank you, Nazi. So for the case study condition, air fryer condition in terms of heat transfer. Okay, a heat component within the cooking chamber is radiates heat directly to the food, which is the air is directed by a special starfish shape similar to the air guide at the bottom, which evenly distributes of heat and direct flow in a vertical direction. So the next is about the air pass over the open bottom of the basket in an air fryer. Hot air circulates rapidly around the food, which is heating all parts of the ingredients even when they are filled up. So this allows for efficient heat transfer and the even cooking of the food. And the last about the case study is about the combination of the top side radiation and bottom side convection produce heat transfer rate. So this is about the flow of the heat transfer in the air fryer. So the next slide. So about the calculation of a heat transfer, the application on an air fryer. So basically, we produce some calculation which is calculate on a cylinder chamber, which is we state at the figure in the slide. So first we find the air fryer properties by the given of the properties, which is diameter of 20 centimeter and length. So from that data, we can produce properties which is air fryer and air properties at the temperature given. So from that, we use some formula that being given in a heat transfer, which is we find the Reynolds number, Nusselt number, and other than that. So we can produce some equation. So from that equation that being given, we can produce a value of heat that transfer in the air fryer, which is we state at the bottom of the slide, which is a Q. So overall, we can calculate what is the value that heat applies on the air fryer. So that's all for calculation in air fryer. So I will pass to the next presenter.
Okay, thank you, Nasrullah. Okay, for the application of the firefighter codes, we know that firefighter codes are usually used by the firefighter in order to protect themselves during the fire and rescue operation. So, for example, when there is structural firefighting, it will be used in the building fires to shield firefighter from the heat, flame, and smoke. For the wildland firefighting, it usually used in the forest fire to protect against the heat, embers, and hot air. As for the rescue operation, it usually one during the vehicle accident, industrial accidents, or confined space rescues in order to prevent burns. And for the hazmat incident, it has a specialized wood that are used to resist chemical and protect against splashes or leaks. Next slide. Okay, for the process in the firefighter course, there are three processes, which is conduction, convection, and radiation. So firstly, for the conduction, firefighter coats usually made from the insulating material, which have a low thermal conductivity in order to minimize the heat transfer to the conduction. So multiple layer, such as ceramic fibers, Kevlar, or other synthetic fire-resistant material used in the firefighter course as barriers against the heat conductions. Okay, for the second process, which is convections, firefighter course employ an air barrier between the layer of protective fabric to minimize the convective heat transfers occurs. So this air barrier will act as the insulation and will reduce the impact of the hot air and gases on the wearer. And for the last process in the firefighter code is radiation. So we know that during the firefighting situation, intense heat and flame will emit radiant energy. So firefighter has been made from the reflective material such as aluminum or other metallic coatings to reflect the radiant heat away from the firefighters. Okay, so by this action, it will help to reduce the amount of heat absorbed by the coat and minimize the risk of burn to the firefighters. Okay, so that's all for me.
Thank you, Daniel. Now I will continue with the case study for firefighter code. So this is the case study that we have find. The firemen wear a fire resistant coat to save his friend in the building which is on fire. The temperature inside the building is 110 degrees Celsius with H equal to 0.5 Wm square. Okay, the outer layer temperature is 60 degrees Celsius and the inner is 40 degrees Celsius. The outer shell of the fire resistant coat is made of a flame resistant fabric A, which has a thermal conductivity of unknown value and thickness of 10 mm. The middle layer of the coat is made of an insulation material such as aramide felt, which has a thermal conductivity about 0.02 Wmk and a thickness of 10 mm. The inner liner of the coat is made of a moisture-wicking material such as Coolmax, which has a thermal conductivity of about 0.3 W/Mk and a thickness of 0.5 mm. We also assume that the coat has a total thickness of 20.5 mm. So we will have to determine the possible material that can be used as the outer shell of the fire resistant coat. So there are two types of materials that is possible. The first one is Nomex and the second one is Kevlar. Since the materials is in series, the convection heat flux is same with the total heat flux. So after some calculation, the thermal conductivity of fabric A is 0.04 W/Mk. Hence, Nomex is the suitable material for the outer layer of fire resistant coat. Next. Now I will continue with the conclusion. In conclusion, the air fryer and firefighter could use different methods to handle heat. The air fryer uses conduction and convection to cook food. It has a heating element that heats up the air inside, which then circulates and cooks the food evenly. The firefighter coat is designed to protect firefighters from heat. It uses special materials to prevent heat from getting in. The coat has layers that don't let heat pass through easily, and it also reflects heat away. Both the air fryer and firefighter coat deal with heat, but they do it in different ways because they have different purpose. And that's all from us. Thank you.